Hello students, we are starting assignment 6.2 and in this assignment we have first 10 exercise problems. In this video we'll take up very first exercise problem of chapter 6. Question is, predict the direction of induced current in the situation described by the following figures. Several figures are given and we are supposed to find out direction of induced current. So we'll start with this one. Now, what is the condition here? Condition is that we have a coil given and say this is point Q, and consider a slightly different figure. So if I consider south pole to be approaching it, the current should be in such a way that the magnetic field due to induced current has south pole facing south, because south is coming close, then the induced magnetic field should have south pole. And then if you curl your fingers in such a way that the let me draw it, your right hand fingers are curling this way, then only you will be able to have north pole left side and south pole right side. So current should be going like this, and then the current direction should be this way. So current will go from Q to R to P to Q. So the direction of current should be Q to R to P to Q. Similar is the story here. Here also south is approaching and then the current direction should be like this. Okay, curl your fingers in such a way that your right hand fingers are like this. Assume this is right hand. I know it's difficult to assume, but you can do it. So then you realize that only for this possible direction, so current is coming and it enters the loop here and then it will leave. So Q to P to R to Q, that should be the current direction. And in this case, so I can say that only for this possibility, south will be created here and north of induced magnetic field will be on the other side. Now for this second coil, as north is receding from the coil, this XYZ coil must have south induced here and north here. Okay, then only it will be able to control the change. Change is north is going away, so how to stop it? So produce south pole here. So induced current should be in such a way that south pole must be created on left end of this coil. Then only it can control this receding of north pole. And for that, the current has to be in this way. So current direction here must be from Y to Z to X to Y. Coming to next one, C. We are closing this key. Look at the key here. When you close it, you are allowing current to pass in this manner. Okay, and then the induced magnetic field will have north pole on left side, south pole on right side. And for increasing current, this coil will feel as if south is approaching it. So what should be its reaction? Its reaction should be to create south pole on left side and north pole on right side. And that is possible only if it allows current to pass in this way. So current should be going from Y to X to Z to Y. Okay, so this should be the direction of induced current in this case. Now here, what we are doing, if we are increasing the current, sorry, now we are told here, what we are told that rheostat is shifted inside. When you take rheostat inside, what you are doing, you are minimizing this gap, and if you minimize this gap, you are decreasing resistance, current will increase. And if current is increasing, see, for now, again, apply the right hand thumb rule and you realize that the induced north pole is on left side, south pole is on right side. And now when you increase the current, this coil will feel as if north is approaching it. Okay, so the condition is north is approaching. How to oppose the change? So to oppose the change, this XYZ coil must have induced north pole on the right side and induced south pole on left side. So how to produce it? Only if the current is in this way. Okay, it is very difficult to visualize in 2D. I assume that this part is outside and this part is inside, and with that consideration, the current direction should be from Y to X to Z to Y. Okay, this should be the nature of induced current. Okay, again, I'll not be explaining this because we have similar case here. So apply that logic and you can decide by yourself what is happening here. Current I decreasing at steady rate. So if current is decreasing at steady rate, uh, the flux is decreasing at steady rate. Okay, and then the induced current should be in opposite manner. That would have happened if current is passing through the coil. So if I consider that this is the loop and current is passing through it, and then there is flux linked with it because of its own current, then it is case of self-induction. But in this case, this is the induced current and the current which is passing through it. And if you look at the magnetic field of the wire, it would be like this. So the magnetic field and the loop both are in the same plane. So there will not be any induction taking place in this case. Self-induced EMF will be observed in this case, but here this wire is carrying current I, and so there will not be any induction in this loop. So that is all about this exercise problem. Thank you.